Up next, we have an oral presentation by เพชรประกาย สิริเผ่าสุวรรณกุล อรันวงศ์พร้อมมูล and ปุญญพัฒน์สินปัญญาเลิศ otherwise known as Pet, Aran and Pun from Mahidol Vichyanusaran School. Today, they will tell us about their ambient detector. This project has won many awards both domestically and internationally, including being the second runner-up for the National Software Contest in 2017 and also participated in the iCreate Fair in Kobe, Japan in 2017 as well. Let's hear what an ambient detector is.
So, thank you, Meiji, and good morning, everyone. Imagine you being alone in a room and you hear this sound. What will you do? You will probably get up of your chair, run to the door, and try to get out of this room safely. I think everyone in this room will be able to get out of this room safely thanks to the inventor of the fire alarm. But this invention that can save us cannot save the other 360 million people. This is the number of the deaf and the hearing impaired all over the world, that if they are in the same situation as us before, they wouldn't know that the fire alarm has rung, they wouldn't know that the fire has started, and when they finally realize the situation around them, the only thing they can do is just struggle and wait for their death. So, as we know about these problems, we try to find some solutions that can save them. Actually, now there are some ways to treat them, like going for a surgery or using hearing aids. But unfortunately, not many of them can have access to these treatments. So what we need is something that everybody can afford and have access to it. So what is it? What do we need? Look in your hands, look on your laps, or look in your pockets. What do you see? What do you have with you? I'm sure that the answer is the mobile phone. In these technology ages, more than 60% of the world population have access to internet and mobile phones. This thing can be more than just a tool for chatting. This thing can be more than just a tool for playing games. This thing can be a tool for saving lives. So as we combine our ideas and we combine our knowledges, we found a solution to save them. And it's become our project, Ambient Detector, an application for detect and warn sounds for the deaf and hearing impaired. So the next part will be presented by Pun.
Okay, so first let's look at our final product in this video.
Hello.
Hello.
Okay, so next, let's look into our features of the application. Our application has two modes, which are recognizing mode and light mode. The recognizing mode can detect the sound type, and the light mode will detect only the sound level. Let's move on to the recognizing mode. First, we have the sound wave in time domain. Then we use fast Fourier transform, or FFT, to change it into the frequency domain. Then we divide the recognizing mode into two parts. The first part is adding new sounds. We use peak extraction algorithm by G.K. Poshka to extract the peak location, which is unique in most of the sound waves. And then we keep the peak location in the database. The second part is the detection part. We will compare the sound data after FFT and the peak location in the database with sound comparison algorithm by InshowView. Then we warn the user if it matches the database, and we detect sounds again. Next is light mode. The light mode will detect only the sound level if it is more than threshold or not. Then we warn the user if it is more than threshold. Our application has 3 types of notifications. The first one is vibration, flashlight, and push notifications. Our application can detect 3 default sounds, which are fire alarm, phone, and car horn. The user can manually add and delete sounds. Moreover, our application has text-to-speech and speech-to-text in English language. The application can also run in background, and most importantly, the application don't need internet connection. The next part is the experiment part, which will be presented by Aran.
So to test out our application, we have conducted 2 experiments. The first one is the algorithm accuracy and the speed. We start by placing our laptop, which is simulated as the sound source, as follows. And we measure the distance of 1 meter from the source and place our phone there. After that, we play our sound and start the stopwatch at the same time. And we wait for the phone to notify us. When the phone does notify us, we record 2 things. The first one is the type of the sound it detected, and the second one is the time it took for the detection. Now we repeat for 5 trials, and then we change the distance. There will be 5 distances as follows. And then we change the sound. There are 8 sound combinations, which include studio noise, fire alarm, car horn, phone, and all of their combinations. Now the results from the first experiment are as follows. The noise rejection, it is at 100%. For a single sound, it is at 99%. And for multiple sounds occurring at the same time, it is at 60%. The reaction time on average is about 3 seconds. Now we move on to the second experiment. We start by opening the application on our mobile phone, and then we record the battery level every hour for 10 hours continuously. Now we plot the graph, and then we analyze by drawing a trend line, and then we calculate the battery life of each phone. We repeat for both recognizing mode and light mode, and then we change the phone. We have tested our application on 4 phones, and we got the results as in the graph. So in both recognizing mode and light mode, and in all of our phones that we tested, it can last for at least 8 hours continuously. Now we went to Rajasuda College to test this application for feedback by real hearing impaired people. And we tweaked our application accordingly by adding text-to-speech and speech-to-text in Thai, and also changing the recording cycle time and the user interface. Now for the conclusion, we have made Ambient Detector, an application that can warn the sounds for the hearing impaired people. The application is satisfied by our testers, and most importantly, the application is lightweight. It does not require internet connection, and it uses a very low amount of memory. Now back to the numbers. The accuracy is at 80%. The reaction time is at 3 seconds. And the battery life is at 8 hours. Now we would like to thank the following people and organizations who helped make our project possible. And we would like to thank all of you sitting here for your kind attention. Thank you very much.
Thank you, Pet, Aran, and Bun, for such a wonderful presentation. We hope our listeners learn something new regarding to integrate science knowledge into practical use.